Good afternoon, students. Let us solve some remaining questions from exercise 1.3, and we are going to solve question number 4. The question is, if fx is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 by 3, so that f o f x is equal to x for all x is not equal to 2 by 3, and what is the inverse of the function f. Now it is given that the function is fx is equal to 4x plus 3 upon 6x minus 4. Now we find out f o f x. F o f x can be written as f of fx, and we can write f, and fx is given as 4x plus 3 upon 6x minus 4, and f 4x plus 3 upon 6x minus 4, we have to put x is equal to 4x plus 3 upon 6x minus 4 here. Then we can write 4 into 4x plus 3 upon 6x minus 4 and plus 3 and whole upon 6 into 4x plus 3 upon 6x minus 4 and minus 4, and after simplifying we can write 16x plus 12 and plus 18x minus 12 and upon 6x minus 4 and whole upon 24x plus 18 minus 24x and plus 16 and whole upon 6x minus 4. Now 6x minus 4 will be cancelled, and we can write 16x plus 18x 34x and upon 24x and minus 24x we can cancel out, and 18 plus 16 is 34, and we can write this as x. Now we see that therefore f o f x is equal to x for all x is not equal to 2 by 3, and this implies f o f is identity function. Then we can say that the given function, therefore the given function f, the function f is invertible, and the inverse of the function f is f itself, because we get the identity function f o f is is an identity function. That's why we can say that the inverse of the function f is f itself. Now we are going to solve question number 5. State with region whether following functions have inverse. We see that a function f from 1 2 3 4 to 10, we can draw the arrow diagram. Let us consider this is set A and this is set B. Here the elements are 1 2 3 4, and in set B there is only one element, and we can say that this is singleton set and a function from A to B, and we see that the image of 1 is 10, 2 is 10, 3 is 10 and 4 is 10. We can say that f is many one, since the function f is many one, and hence it cannot have inverse, because we know that any function may have inverse function if the function is 1 1 and on 2, but we see that this function is not 1 1, this is many one. That's why this function cannot have inverse. Now third part of this question number 5. A function is given as a function h from 2 3 4 5 to 7 9 11 13, and which is defined as h is equal to 2 7 3 9 4 11 and 5 13. We can see that let us solve this question by arrow diagram. Here are 4 elements 2 3 4 5. Let us consider this is set A1 and this is set A2. Now the elements are 7 9 11 13, and by the definition of the function is defined as h is equal to 2 7. It means the function works such that the image of 2 is 7, the image of 3 is 9, the image of 4 is 11, and the image of 5 is 13. It means it is clear that this is a 1 1 function. It is clear that h is 1 1 and on 2 also, because each element of set A2 is mapped with distinct elements of set A1. Each element of set A2 is mapped with the distinct elements of set A1. Therefore, it is and on 2 also. And we know that if any function is 1 1 and onto, then that function is also invertible, and this function have inverse. This function has inverse. This implies the function h has inverse. Now we are going to solve question number 6, which is a very typical question. And in this question, so that function f from closed interval -1 to 1 to r, where r is the set of real numbers, given by fx is equal to x upon x plus 2 is 1 1, and find the inverse of the function f from -1 to 1 to range of f. And hint is also given in this question, and hint is for y belongs to r, y belongs to range f, y is equal to fx, and fx is given as x upon x plus 2 for some x in closed interval -1 to 1, i.e. x is equal to 2y upon y 1 minus y. Now to solve this question, here the function is f from -1 to r is given as fx is equal to x upon x plus 2, and let fx is equal to fy. We take an element y and we equate fx and fy. Then we can write x upon x plus 2 is equal to y upon y plus 2, and this implies by cross multiplication we can write xy plus 2y is equal to xy plus 2x, and this implies we can write 2y is equal to 2x, and this implies x is equal to y. And we know that if fx is equal to fy implies x is equal to y, it means this function is 1 1. It means the given function f is 1 1. Again, it is clear that the function from -1 to 1 to range f is on 2. This function is also on 2. Therefore, the function f is 1 1 and on 2, and therefore and therefore the inverse of the function f from -1 to 1 to range f exists. Now we have to find out the inverse of the function. For this, let a function g from range f2 -1 to 1 be the inverse of f, and let y be an arbitrary element of range f. Now we see that since the function f from -1 to 1 to range f is onto we can write y is equal to fx for some x belongs to the closed interval -1 to 1, and this implies y is equal to x upon fx is x upon x plus 2, and this gives x is equal to 2y upon 1 minus y, where y is not equal to 1. Again, let us define the function g from range f to -1 as gy is equal to 2y upon 1 minus y, where y is not equal to 1. Now we find out g o f x. We can write g o f x is g of fx, and we know that g fx is x upon x plus 2, and gy is 2y upon 1 minus y. Therefore we can write 2 into x upon x plus 2 upon 1 minus y. Y means x upon x plus 2. X upon x plus 2, and this gives 2x upon x plus 2 and upon x plus 2 minus x upon x plus 2. We can cancel x plus 2, and we can cancel x, we can cancel 2. This gives, this is equal to x. And also FOG y. We can write f of gy, but gy is 2y upon 1 minus y, and fx is x upon x plus 2. Then we can write x, it means 2y upon 1 minus y upon 2y upon 1 minus y plus 2, and this gives 2y upon 1 minus y upon 2y plus 2 minus 2y and whole upon 1 minus y. We can cancel 1 minus y and 2y, and we can also cancel 2. This implies FOG y is equal to y. Therefore, GOF is equal to, we can write GOF is equal to I and the closed interval minus 1 to 1, and FOG is equal to I range of f, and therefore we can write f inverse is G. It means G is the inverse of f, and f inverse y is equal to 2y upon 1 minus y, where y is not equal to 1. Now solve the remaining questions, and after this we will start binary operation, which is the last topic of this chapter. Thank you.